Hello guys, yeah, welcome back to my class. This is the continuation of our 2021 past question solution series on physics. So in our last session rather, we stopped at question 20. Yes, we stopped at question 20. So today we continue from question 21. So question 21 says, from the above, the polarity of X and Y ends of the magnet are A, north and north, B, north and south, C, south and north, D, south and south. So for you to get to answer this type of question, you must have to familiarize yourself with uh, with uh, the polarity of magnetic bar magnet, right? So we have two polarities, which is north in a single bar magnet. We have north and south. We have north and south, and the magnetic field line always emanates from what? From north and enters through the south. It emanates from north and enters through the south. So meaning that the direction of the magnetic field line for the north is always going outside, and for the south is always coming in. Look at this is how it is, like this. Then for the south is always inward, inward, and for the north is always outside. So if you have this idea, you'll be able to, from what I've just done now, be able to answer. So if it is not north, so from what we have here, so we have I don't even need to draw this. So we have this magnetic line is going out. This one is also going out. This to tell you that the polarity here is not, and the polarity here is also what? Not. Is that understood? So that's about that, just as simple as this. So the correct answer here is that it is not and not, option A. So the next question, which is question 22. Question 22 says, a body of mass 500 grams is undergoing a circular motion with a velocity of 36 kilometers per hour with a radius of 40 centimeters. So the centripetal force on the body is, so you're looking for the centripetal force here. So if you read your book and prepare for the exam, you should know that this is under circular motion. So we are uh, given that the mass m is 500 gram. So except otherwise stated, quickly convert to kilogram. That is 500 divided by 1000. That will give us our mass to be equal to 0.5 kilogram. Then the velocity is given, velocity v was given to be 36 kilometer per hour. So you also have to convert this one to meter per second. 36 kilometer per hour is as good as saying 36 kilometer all over what? 1 hour. Is that clear? 1 kilometer is equal to 1000 meter, and 1 hour is equal to 3, 3600, right? Second. Is that correct? So from here, 3600 second, right? So from here we have, so in order for you to convert from, this is a bigger unit to a smaller unit, you multiply by the rate of conversion. So I'm going to have V will now be equal to 36 multiplied by the rate of conversion here is 1000 multiplied by 1000 all over what? 1 hour is the same thing as 3600. Is that clear? So from here, I'll have my velocity V will now be equal to uh, 10 meter per second. This 0 cancel, this is 0. This 36 go with this 36, so I will have it 10 meter per second. And we are giving radius to be equal to 40 centimeter. In the same vein, convert it to meter. That will be 40 all divided by 100, so that my radius is going to be 0.4 meter. So having done this, the next thing is to recall the relationship between centripetal force on all these parameters, the mass, velocity, and the radius. And we recall that F, the centripetal force, is equal to mv squared all over what? R. So now plug in your value. Mass is 0.5 multiplied by V, which is 10. We have 10 squared, all divided by the radius, which is 0.4. So that will be 0.5 all multiplied by 100, then divide by 0.5 multiplied by 100, then divided by 0.4. So when you do this, your R, your F, the centripetal force will be equal to, centripetal force FC will be equal to, that is 5 divided by 0.4. Is that correct? So that FC, if you divide 5 by 0.4, that should give us a 125 Newton. 125 Newton. Is that clear? So that is about question. That is about question what? 22. Question 22. So the next thing is question 20. Okay, it's supposed to be 50, sorry. It's 50 divided by 0.4. 50 divided by 0.4, that will give us 125. The answer is still correct, just because. So that's about question what? 22. So moving on to the next question, which is question 23. So question 23 says, in Fleming's right-hand rule, the thumb, the forefinger, and the middle finger, if held perpendicular or mutually at right angles, they represent what? So what does the thumb represent? The thumb represents the motion, thumb, right? Motion. Exactly, motion. The forefinger represents the field. And the second finger, the middle finger, right? The middle finger represent what? The current. The middle finger represent the current. So the correct answer, or the induced current, correct answer is option A. Exactly. So the next thing is question 24. Question 24 says, a new thermometer was constructed which measures temperature in degree mellow, right? The lower and the upper fixed point are negative 20 mellow and 200 degree mellow, respectively. So the equivalent of 150 mellow in Kelvin. So we are looking to a kind of the equivalent conversion of this into what? Into Kelvin. So to achieve this, you should know that it's like a scale. So the new scale, just manage this one. The new scale for temperature is that of this, and for the standard one, which you already know, that of Kelvin, is this, for instance. So, and it was said that the upper fixed point for the mellow, they said the lower and the upper are this and this respectively. So upper fixed point is 200 degree mellow, and the lower fixed point is what? Negative 20 degree mellow. And we all know that for Kelvin, the upper fixed point is 373 Kelvin, and the lower fixed point is 273 Kelvin. This is a standard, right? So when the temperature in the mellow reads up to 150 degree mellow, what is the equivalent of that reading in Kelvin? So assuming the temperature in mellow read at what? 150 degree mellow. What is the equivalent in Kelvin? So we don't know. Let us call it T, right? So here you now take a proportion. Taking a proportion, you subtract this from the lower fixed point, right? Then also subtract the upper fixed point from the lower fixed point. Then equate it and do the same thing. So I'm going to have 150 minus negative 20 all over 200 minus negative 20 all equal to the same thing here. I'll subtract this one from the lower fixed point and also subtract this one from the lower fixed point. So I'll have t minus 273 all over 373 minus 273. So doing, I'm going to have, then you simplify further. Let us manage our space here. You simplify further such that you have 150 plus 20. That's going to give us 170 all over 220. 220 equal to t minus 273 all over 100. Now cross multiply. When you cross multiply, I'm going to have t minus 273 all into bracket what? Let's say, okay, let me just put like 220 is better into t minus 273. Remember, it's still like multiplication. When I multiply this, I'm going to have 170 multiplied by 100. Is that clear? So I can say divide both sides by what? 220. Here is 220. So that this one will go with this. I'll have t minus 273 equal to what? This 0, we cancel this 0. I'll be left with 1700, 1700 all over 22. So that I have t minus 273 equal to, what is 1700? 1700 divided by 22. That will give us a 77.27. 77.27. Therefore, t will now be equal to 77.27 plus what? 273. When you do that, you add it plus 273. That will give us a 350 Kelvin. 350 Kelvin. That's option option what? Option D. I hope this is understood. So quickly, we'll move to the next question, which is question 25. Question 25 says that a body of mass 800 grams start from rest and accelerate uniformly at 2.5 meter per second squared. If a distance of this 12.8 meter is covered, calculate the kinetic energy gained by the body. So here we are looking for kinetic energy, and we all know that kinetic energy has this formula, which is a half mv squared. You can write it as what? mv squared all over 2. But in what we have here, we don't have the final velocity here. So we can use the parameters from here to get our final velocity. So we are given that mass is equal to 800 gram. Convert to kilogram, that will be 800 divided by 1000, which will give us a 0.8 kilogram. Is that clear? And the acceleration A is equal to 2.5 meter per square second, and the distance S is 12.8 meter. So, and according to the question, it says it starts from rest. So when it starts from rest, something is hidden there. That is our initial velocity. U is equal to what? 0. So you all know that this is going to lead to equations of motion. We have basically 3 equations of motion, which are what? V equal to U plus AT. We have V squared equal to U squared plus what? 2AS. And we have S is equal to UT plus half AT squared. So from here, in all our parameters, there's none that give us a time. So we cannot use this formula, we cannot use this one, we cannot use this one. So this is the appropriate one to apply. So in so doing, we apply the formula to get our final velocity. So from here, which is v squared equal to u squared plus 2as. So that our u squared, you have v squared is equal to u squared is 0 plus 2 multiplied by a is 2.5 multiplied by distance, 12.8. So we have v squared now is equal to, we said 2 multiplied by 2.5 multiplied by 12.8. That gives us a 64. So we have 64, so that v will be equal to the square root of 64, which will give us 8 meter per second. So we have gotten our v. Then we can now come back to this formula, which is a kinetic energy equal to what? Mv squared all over what? 2. Then we plug in our value. M is 0.8. V squared is 8 squared. That will be 64. All divided by what? 2. So that implies that our kinetic energy will be equal to 64 multiplied by 0.8. That will give us a 51.2, all divided by 2. When you do that, that should give us a 25.6. That is 25.6 joules. I hope this is understood. So that is about question 25, and the correct answer is option B. So moving on to the next question, which is question 26. So question 26, we have this system said that a 2 kilogram mass on a smooth inclined plane is connected over a smooth pulley. Take note of all this: smooth inclined plane and smooth pulley shows that there's no friction. So there is a movement of what? Of the masses. So it's connected to over a smooth pulley to a 3 kg mass as shown in the diagram above, right? So the acceleration of the system, you're looking for the acceleration of the system. Exactly. So when you have this system, you can redraw it for a better analysis. Here we have, this is the horizontal floor, and this is the inclined plane. This is the inclined plane, right? Let's leave it like this. This is the inclined plane. And the body, here, there is a pulley system here. There's a pulley system. And we have this body 2 kg, 2 kg on a smooth pulley. The body is 2 kg, that is the mass. And connected through a string over this pulley, then to another body of mass 3 kg, right? Good. And this is at an angle 30 degree. So I have done a particular video that is explicitly explain what I'm going to do here now. So when this happens, we all know that the weight of the body is acting downward. The weight of the body is acting downward. So the weight, W, is equal to mg. So the component of this body along the inclined plane is found to be equal to mg sine theta. And the component, we have the normal reaction, which is always perpendicular to the plane and equal to the component of what? Of the weight perpendicular to the plane, and this mg cos what? Cos theta. I have done a video that explains how we arrive at all this one. So this is the normal reaction. So now we look at it. This particular body has a rope, right? It has a rope, and therefore it has a tension T, right? And also this is also a rope. The tension, as the weight of the body is going down, right, of the 3 kg body, W is equal to what? Mg. The tension will be what? Up. So we call it T. So since there is motion, because this is smooth and this pulley is also smooth, therefore there's going to be an unbalanced force, right? That unbalanced force is equal to mass times what? Acceleration. Also, there's going to be an unbalanced force, and that unbalanced force is so mass times what? Acceleration here. So we can call this one M1, call this one M2, as the case may be. So now, let's now look at it. The body here, 3 kg, is definitely bigger than what? 2 kg. So the direction of the movement is going to be like this. In that case, the unbalanced force is here. T, the tension here is bigger than what? The horizontal component of what? Of this mass 2 kg. So therefore, the unbalanced force is going to be T minus that horizontal component, which is what? Mg sine theta equal to that unbalanced force that give it acceleration. That is mass times what? Acceleration. So here we have T minus, the mass is 2. We have 2 multiplied by G. Remember, we are working in terms of G. Then sine what? Sine 30 degree equal to what? 2 times what? A. Sine 30 is 0.2. That is T minus 2G times sine 30, that is half 1 over 2, equal to what? 2A. So that 2A cancel 2, I'll be left with what? T minus what? G equal to what? 2A. From here, I can make T subject of the formula. T will now be equal to 2A minus what? Minus G. So I can call this one equation 1. So now, considering the mass 3 kg, the unbalanced force in mass 3 kg, the mass here is downward, is bigger than the tension here. So the unbalanced force is going to be mg minus what? The weight, minus the tension rather, equal to what? Ma also. So m here is 3 multiplied by g minus what? T equal to what? 3a. So in the same vein here, let us manage our space here. Then we now have we have still continue with our equation here to simplify it further. We have 3g minus what? T equal to what? 3a, right? They make t the subject of the formula. So we have minus t equal to what? 3a minus 3g. Then to remove this, the negative on t, they multiply everything by negative. That will be t. If we multiply negative t by negative, it will give us positive t. Then multiply negative with this, give us negative 3a. Negative to this give us positive 3g. Then just rearrange it. We have t equal to 3g minus 3a. So this is equation what? 2. Now, since we have both of it are what? T. So we can equate equation 1 and equation 2. So equation 1 is 2a minus g equal to equation 2, 3g minus what? 3a. So let's bring the ones with a together. We have 2a minus 3a crossing the equality sign, change to what? Plus what? 3a equal to 3g, turn going to the negative side, turn to what? Plus, right? Yes, turn to plus g, right? No, this one's supposed to 2g, this one's supposed to be, when you're making, I think we make mistake here. We are making this object of the formula here, it's supposed to be 2a plus g, not minus. Thank you. So that is going to be plus. So when this one crossing the equality sign, turn to what? Minus g. So that I have 5a here equal to what? Equal to 2g. So from here, let's manage our space. From here, we have divide both sides by what? By 5. We have 5a equal to what? 3g. Divide both sides by 5, right? Let's go to 2g rather, please. 2g. So that 5 we cancel 5, so that a will be equal to 2g all over 5. So which is option D. Is that clear? So this is how to apply this type of approach this type of question. So that's about that's option D. That's about question 26. So question 27 says a rod of length 2 meter becomes 2.0 meter when taken from I to steam. What is its cubic expansivity? So this is also simple. This is another linear expansivity, but all the parameters given to us is for linear calculation, linear expansivity calculation. But when you have this type of question where you are given parameter for linear and you ask to calculate a cubic, then you remember the relationship between linear expansivity and cubic expansivity. that cubic expansivity is equal to what? 3 multiplied by linear expansivity. Now here is the original length. L1 is 2 meter, and the final length L2 is 2.01 meter. Then they say from ice to steam, that is telling you that ice temperature, which we all know to be what? Theta 1 here is 0 degrees Celsius, and the steam temperature, we all know that is theta 2 to be what? 100 degrees Celsius. As simple as this. So from here, we can calculate our linear expansivity. Linear expansivity is equal to what? L2 minus L1 all over L1 change in what? Change in theta. So from here, we can just plug in our value. We plug in our value, which is here we have alpha will be equal to uh, L2 is 2.01 minus L1, which is 2, all over L1, that is 2, multiplied by change in theta, that is theta 2, which is 100, minus theta 1, which is 0. So I have alpha equal to this minus this give us 0.01 all over what? 2 multiplied by 100, that will give us 200. So when you divide 0.1, you have a 0.01 divided by 200. That will give us a 5 exponential minus 5. So you have 5 times 10 raised to power minus 5 per Kelvin. Then you now come here, the cubic expansivity is equal to 3 alpha. That will be equal to 3 multiplied by 5 times 10 raised to power minus 5. Is that clear? And when you do that, that should give us a 1.5 times 10 raised to power minus 4 times 10 raised to power minus 4 per Kelvin. So that is option, that will give us option C. So moving on to the next question, which is question 28. It says, cylindrical lens is used for the correction of which of these eye defect? It is for astigmatism. Please take note of this type of question. It's for astigmatism. The next question is question 29. The electrolyte used in a Leclanché cell, which is a primary cell, is ammonium chloride. So, and last on this particular session, so the quantity of heat needed to convert a substance in the solid state to liquid state. There's a change of state, a change of phase. So that from a solid to what? To liquid. That is a latent heat of fission. Is that understood? So this is where you're going to stop here in our class and continue from here in the next class. Please, should you have any question, please drop it in the comment section and be rest assured that I'll take it over from there. Thank you for your time. See you in the next class.